I am Morten Nielsen, and in this video I'm going to discuss how to generate this additional input for site assessment. And we can start by the mean wind climate. And I can show that for this project, then I had a WASP project, and here's the station where there was some observation, and then I imported the observed wind climate and converted it to a generalized extreme wind climate. WASP applies the wind atlas method, and that means that you take the observed wind climate and then you kind of remove the effects of the local terrain, and you also use the geostrophic drag law to convert the wind climate to an idealized wind climate over flat terrain, and that is what we call the generalized wind climate. And then we can take that wind climate and convert it to a predicted wind climate using the same models in the reverse order. And we are going to do exactly the same in ShowCFD. And in this context, then it's important that we use the CFD solution both when we do the generalization, that is up arrow, and when we are making the predictions in ShowCFD. So this is why it's important that we are using the CFD solution here when we are making this generalized wind climate file and not the normal linear solver of WASP. So then you can save the generalized mean wind climate from WASP and then import it into ShowCFD by clicking here in the site assessment input, the first option here, and then you just select your file like this. And when you have that file, then you remember that the flow conditions upstream was for flat terrain, so that was actually a generalized wind. So you can use the speed up factors to calculate what the wind speed is or the wind climate is everywhere here, and then you can show what is the probability distribution for different sites in the flow domain. And you can calculate the power density, and you can also do this averaging for the wind shear and flow inclination fields here. Then the next thing is with the extreme winds, and that works the same way. You're going to import something which is generated by WASP engineering. But one of the problems is that WASP engineering is using another flow model, which normally isn't WASP CFD. But we have one trick. If we know the coordinate of the mast, and it has to be inside this this flow domain here, then we can say export site conditions, and then type in the position of the mast and the height. It was a very low mast. I remember it was a experiment which was done long time ago, and then the conditions for the generalized condition. This is just a standard one, and the latitude, so you get the Coriolis force for the geostrophic drag law correct, and then you can export this to file. So here I have a WASP engineering project for the site of interest. The measurement mast is at the center here. It's called port 08, and that this is the measurement height, and then I want to calculate an extreme wind climate with the spectral correction method. This is a method which is using a combination of local measurements and a longer time series from a database, which is calculated by a global model. And then you click here, and then select the site. That was correct, and also the height was also correct. And normally I would, in WASP engineering, I would click calculate here, and then it would use the built-in flow model Lincom. But we can also import flow corrections, and so we will take the ones which we just exported from ShowCFD and use this ones instead here. And then we need a time series. It's probably this one, and then we can click next. Now it's contacting the server. and now it's ready, and then it's suggesting a file name. I'll just say new generalized extreme wind climate, and then it's here. I can go here and then I will export this to file. So back in ShowCFD we can now find this button here to import the generalized extreme wind climate which we just exported from WASP Engineering, and then find it and then open it, and then we can see this extreme wind speed based on the observations, and we can select new sites and make new predictions here. All these dots are for individual years, and we can also see the directional distribution or polar distribution. These are these dots here. So most of these high winds are at this side are coming from southerly directions. So let's continue with some of the additional site assessment inputs. The wind turbine class we can change here in this menu here. We can select the wind turbine class and the turbulence subcategory. If we select class S, then we have some more options to specify that, and we can look in the information from the manufacturer. And also sometimes it's a tropical subcategory that is with the extra high extreme wind conditions. And then we can go to reference air density. That's mainly when we want to calculate the power production here, and also maybe the evaluation of the extreme winds. So here are some conditions here for a reference site at some height, and then the model can calculate what is air density at other elevations about this reference site here. And if you don't know all of these conditions, then you can go to WASP, and here you can click on the generalized wind climate here, and right click on it and say show, and then say the climate context. Then and if you press get here, then WASP is looking up these this information in a database for this particular project. If you have been working with a WASP project, then you probably already know the power curve and thrust coefficient, and then you when you are working with ShowCFD, then you just import that turbine file in WASP format.